Hi guys, this is Leela. Welcome to my channel Leela WebDev. In this video, we will learn about the container creation workflow in the Docker engine. So let's try to see this one. So I am opening the slideshow. In the previous videos in our Docker tutorial, we have seen that how to create the containers like Nginx and the MySQL application. So these are all the different ways how we can create the Nginx and what are the different options also we have seen for creating the container. Also we have seen what are the commands we have to execute and what are the options we have to pass. So what are the different types of commands also, the Docker commands we have seen, and how we can execute it also we have seen, and what are the different types of options for creating the container and what are the different options we have to pass. Those all things also we have completed. Now let us understand when you try to create a container, what will happen behind the scenes or beyond the scenes of the Docker. So now you are creating a container. Now you are able to see that the container is able to create with the help of Docker engine. But what will be happening behind the scenes when the container is trying to create? So while container is creating, what are the things that will happen or what are the steps which will happen? Let's try to see. We have seen just a high level view that CLI will talk to the daemon. Daemon means here nothing but a Docker server, and the daemon will look for the image. If the image is not available, it will download and then it will start creating the container. So this is the high level view. So that means in the high level view we have seen that the CLI, in the CLI we will talk to the daemon and the daemon will look for the image. If the image is not available, it will download and then it will start creating the container. That's it. Now let us understand in deep about this container creation process. So Docker CLI is used for executing a command. Like Docker container create or so what we will be using the commands here in the Docker CLI. So like Docker container create or the Docker container run command. So these are the two commands which we will be using, or any command which you are trying to execute in the Docker CLI, that Docker CLI is used to execute the commands. Now when you execute this command, these commands will pass the information to the Docker daemon. So the commands will pass the information to the Docker daemon. Now the Docker daemon will receive this information from the CLI with the help of REST API call. So this one also we have seen. So the Docker daemon will receive this information with the help of REST API call. We have seen the Unix socket, right? So I have shown you that it will be available in the var/run/docker.sock. So that Unix socket. So it will be using this REST API call in order to transfer the information from your client to the daemon. So in order to transfer the information from your client to daemon, so the Unix socket will be taking help of the REST API in order to transfer the information from client to the daemon. Here daemon is nothing but a Docker server. So here you will be confusing the daemon. What is the daemon? So daemon is nothing but a Docker server. Now the daemon calls the container D. So here you need to understand that now after receiving the information, the daemon will call the container D. What is this container D? If you remember at the time of Docker installation, I have told you in our earlier videos. So when we are trying to install the Docker engine, we have installed the container D along with the docker-ca, docker-compose, docker-buildx, something like that. So when you are trying to install it, so we have also installed the container D also. This means that the tool which creating the container in the background is not Docker, it is container D. So the container is created by not the Docker, it is container D. That means Docker daemon is calling the container D to create the containers. Docker daemon uses the gRPC calls, which is like CRUD style API. So Docker daemon uses the gRPC calls, which is like a CRUD style of API, to transfer the information to the container D. Now container D will receive the information with the help of gRPC call from a Docker daemon. So how the Docker daemon and the container will communicate, container D, using the gRPC calls. How the CLI and the Docker daemon will communicate with the help of REST API calls, Unix socket. Now when you execute a command, Docker container run the image name, that container D will see whether you have that particular image in the local system is present or not. If it is not available, it will download the image from the repository. That is nothing but by default, it will check in the public repository, that is Docker Hub. So here when you execute a command, the Docker container run command, with the image name. So you will be giving the image name, right? Docker container run and nginx the image name. So the container will check whether you have that particular image or not. If it is not present means then it will try to download it from the public repository, that is Docker Hub by default, and then it will place it in your local system. Containerd will create a OCI bundle. So using that image, it will create a bundle, that is OCI bundle from the image. The image details will be given to your container as an OCI bundle. So here the images and all those things will be created as an OCI bundle. After this, so when the containerd creates the OCI bundle, after this runc will create a container using that OCI bundle. So now we will be able to see a runc. So runc will create a container using that OCI bundle. Containerd will create the OCI bundle and runc will take that OCI bundle to create a container. So this is the overview. After that, runc interacts with the OS kernel to construct the needs needed to create a container. So here runc interacts with the OS kernel. So we already discussed, if you remember, we have something like a lib container. I have told you about the bundling thing. So it will contain a kernel namespaces, C groups, file system and all those things. It will be bundled and you will be having the Docker by default. It will be using the lib container. In our previous videos I have explained you. So lib container will contain the bundles like kernel namespaces and C groups, etc. So now your runc will call that particular lib container to do that particular actions. This means by using namespaces and C groups, your container will be created in the backend. After that container process will start, after the container creation, the process will start as a child process under your Docker main process. So now the child process will be created for the container creation and it will be under your Docker main process. After the container process has been created, so when the Docker process has been created, runc will assume that the container has been created successfully and then it will exit from the task. So when the container process, the process has been created means then the runc will assume that it has been created successfully, then it will exit from the task. Finally, you will see the container has been created in the container has been created and it is running in the background. If you try to see the visual representation of the process, then you will be able to see here. I will explain you here. First, the Docker CLI, you will write the command Docker container run or Docker container create, whatever the command. For creating the container, you will type the command here Docker CLI. And the Docker CLI will communicate to the Docker daemon with the help of the REST API. So this will be the help of this Unix socket and it will use the REST API calls and the command will be here sent to the Docker daemon. Information will be sent. And the Docker daemon will receive the information that we need to create a container with a image name, so with the particular image, and it will transfer to the containerd using the gRPC calls to tell to the containerd that we need to create an container. So now the containerd will take that image and it will create a OCI bundle and it will send it to the runc. Okay, the containerd will create an OCI bundle and it will send it to the runc. And runc will take help of this lib container which contains the namespaces and the C groups. So these are all the namespace and all. It will take the help of this lib container and all those things, and it will create the container and a process will be created for this one. So now when the process ID has been created for this one, automatically the runc exits that the container has been created. So now you will be able to see the container status, and in the console output you will be able to see that the container successfully created, or if an error occurs, say the error, whatever the thing it will be happen, the status of the container you will be able to see in the console output. So this is the whole process how the container will be created behind the scenes. So that's it guys. Hope you understood about this high level overview how the container will be created in the Docker engine. If you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you.